and it's a very different kind of topic, and people usually like this topic, as I also like this topic. It is different matter. It is very difficult to understand, but we usually like this topic, and it's a not a traditional topic actually. It's a different topic. Philosophy is there, mathematics is there, and observations is obviously there, and whole and soul. This is a very interesting next 35 to 40 day or for this particular classes. So let's first I will discuss what are your course content for examination point of view, and then we will try to learn this subject in very deep way. So let's try to go for it. So I make your course content for this program actually for I will start tools and postulates of quantum mechanics. Tools and postulates of quantum mechanics, and once we will try to understand these tools and postulates, then we will try to apply these tools and postulates on one-dimensional system. And in one-dimensional system, we will try to learn free particle, then step potential, and then particle in a box. We will learn different types of box, infinite box, finite box, everything will come into particle in a box. And then we will go for harmonic oscillator. And obviously we will also analyze Dirac delta function, Dirac delta potential. And once we will go for the one-dimensional system, we will just try to go into two-dimensional, 2D and 3D system. Here we will again go for all these free particle. Step potential is not there. Free particle, particle in a box, harmonic oscillator, everything go into 2D and 3D in Cartesian coordinate. So first we will discuss in a Cartesian coordinate. And then we will go for the polar coordinate system or a spherical polar coordinate system. So we have to learn angular momentum. Then this is third one actually. This is third one. This one is fourth one. And then we will try to learn the spin. Then we will try to learn radial part. Radial part. These are the rotational symmetry, and this is the translation symmetry. Radial wave function. In the radial wave function, we will learn hydrogen atom. And after then, if we are going to finish all this thing, then we will go for approximation method. In the approximation method, we have different types of mathematical method that will be used to understand the quantum mechanical system. So first we will go for, this is 7. So first we will go for perturbation. In the perturbation, you will see non-degenerate, degenerate, time dependent, everything we will cover into this. Then we will go for WKV. and then we will go for variational principle. So this is the variational principle. So these three are the approximation method, and then we will go for relativistic quantum mechanics. Then we will go for a scattering actually, scattering, and then we will go for, this is eighth, and then we will go for relativistic quantum mechanics. So these are the complete theory of complete course according to your examination, and this will cover all the net, gate, JEST, TIFR, everything. So this is the main thing for up to master's level. You can just try to understand this thing. Okay, so these are the topics. If you want any suggestion, you can just ask me anything. If you have any doubts, we will cover each and every bit. So I have just write the summary. The thing will be very deeper. So we have the lot of inside thing in this particular name. Okay, so this is the beautiful course structure. What you need into quantum mechanics, obviously the basic understanding is very important, but examination point of view, the mathematics, the application of mathematics is very important. So just try to recall all your integration, all your whatever you have done into the mathematics, just try to recall. And fortunately we have parallelly mathematical physics class, so there is not any problem to doing the course of this particular quantum mechanics. So let me start with the history of quantum mechanics, and I am just going before starting of the quantum mechanics. I will take the name of some experiments, and what this experiment reveals, we will just try to know. And then we will try to understand two different experiments which will tell lot of stories about quantum mechanics. Now, before the starting the all these stories and all this concept of quantum mechanics, let me tell you one very important thing. What are these very important thing? The thing is, we have to fight the battle with our perception actually. This is the most important thing before to understand before the learning of quantum mechanics. Why I am saying that we have to fight the battle with our perception? Because we are in our surroundings. We are every day from our birth, we are seeing lot of experiments, lot of events happening, and these events can be easily explained by the Newtonian mechanics and classical mechanics. So what will happen in general as a psychological point of view, what will happen? You will be so much biased towards classical mechanics. That is very natural, because the data in our mind is fed such a way that we assume that this is the fact and this is the only fact, and we just believe only on classical mechanics. And once the quantum mechanical phenomena comes, we are making the blunder that we are just comparing this classical and quantum mechanics thing, and we are using the classical tools to understand this thing. This is the main blunder done by a lot of peoples. The thing is that quantum mechanical treatment is quantum mechanical treatment, classical treatment is classical treatment. You cannot simultaneously use quantum mechanical treatment and classical treatment. That is the most important thing. So what you have to do, you have to fight the battle with your perception actually. So who will help to fight the battle in our perception? Obviously, we need some basically arms, some tools to fight this battle. Obviously, there are two arms or two things that will help us to fight this battle against the classical mechanics, against the perception we have generated from the classical mechanics. The first one is the observation in the lab, Whatever we have observed into the lab, this is the most important thing. And second thing, to understand this observation, we have beautiful tool of mathematics. And we have developed our mathematics such that we can understand the quantum mechanical phenomena. It is not here that hence our mathematics is something like that. So why this observation is there? No. First we will see the observation, we will see the basic experiment, we will measure the result, and we will try to explain it with some mathematical tools, some mathematical models, some mathematical postulates. And sometime it may support classical features, sometime it cannot support classical features, sometime it may support 70% to 80% of classical features, but 20% not classical features. That is different issue. So be ready for battle with your perception in the next all classes of quantum mechanics. I am not saying that classical mechanics is wrong. I am not saying that quantum mechanics is correct or wrong. What I am saying that there are n number of events, n number of observations in our nature. To understand these observations, we have n number of tools. The two tools are very important in the physics mainly. The first we have used into the classical mechanics. Second, we are going to use from the quantum mechanics. So this is the actual thing of the quantum mechanics. And yes, do you understand it or not understand it? It depends to you. But thing is that we have to apply the thing. And one next thing is most important thing is the belief. Believe on what? Not believe on me. Believe on two things. Believing on experiment, the result of experiment, and what the mathematics generated to explain this experiment. So you need to believe that. You need to generate belief. Then only you can learn quantum mechanics. I am not saying that you will understand quantum mechanics or not. What I am saying, only these way you can learn quantum mechanics. So this is the most important thing, and I have just tell you before starting the quantum mechanical thing. So let's go for the historical development, next 10 minutes for the historical development of quantum mechanics, and then we will explain two experiment. Let's see, are you able to understand it or not? So let's go for the historical development of quantum mechanics.
Sir, you suggest any reference book for this course?
You can reference book, yes, there are n number of books, but listen, I find the people who use Jetli mainly. Jetli is good book, not bad book, but it is very bulky. It's a very bulky book, and lot of questions are given is a worked out. They are solved question. Most all important question are solved question. So I don't believe into seeing the solved question and understanding the thing. So obviously I will not go for Jetli for you. What I will suggest, you can go for a Griffith. Griffith is a very nice book up to master's level. Why? Because it's not a bulky. It's a very comprehensive. Second, there are very few worked out question. So when you will solve any unsolved problem, you will get confidence. So for examination point of view, if at this present time, if you want any book to read, then you can go for Griffith. But I will suggest you go for my notes. This is more than enough. This is more than enough for your whole life for the basic quantum mechanics. So, but yes, book is very important for life. So first book you can purchase for the quantum mechanics is Griffith. And then there are n number of books. The books written by R. Shankar is very nice book. The book Cohen Tanoji, 2-volume books. is very nice book, but they are this sort of bulky book. So they are 2 volume and it will be very bulky. So you can use Cohen Tanoji, but they are not for the examination point of view. They are for the research and all different kind of. Yes, Jetli is also good book. If you are believing that we should go first solve problem, then I will go unsolved problem, then you can use Jetli also. So these are, but I suggest you, whatever the book you refer, don't see the solution. Once you see the solution, then you will bias towards the solution and you will lose your basic instinct of understanding the subject. Solve only one problem on a day, don't worry, it is more than enough, but that should be unsolved. So this is the most important thing. Okay, so
Sir,
yes,
good evening, sir.
yes, good evening.
Sir, how much marks it will cover in net? Something
It will
like
cover maximum marks into your every examination, so don't worry about this. Okay, maximum marks 30 35 for the net examination, and it is the most important topic I can say. After mathematical physics, quantum mechanics, and same to mathematical physics, quantum mechanics have same weightage. So sometime it will 30 35, sometime maybe more than that. So it depends. Okay. Okay, so what are the historical development? I am not giving the basically in which time this is happen, and I'm just giving the name. So first, there was an experiment known as photoelectric experiment. Photoelectric experiment will tell you that light is behaving like particle. I'm not going in detail of this all thing because I assume that you have done into your graduation time. So if you want to go for this detail, you can go for the Arthur Bezer, you can just go, but these are not asking in your examination. But conclusion you should know, light is behaving like a particle. But you know, light is electromagnetic wave and it is wave also. So this is the extra information about the light. Compton effect. Again, it is say that particle nature of light. So from the quantum scattering, we have seen that light, we can explain quantum spectrum by the believing that light is a particle, and that particle named as photon, and which is moving with that is massless particle, and with some energy, this is the bundle of energy, this particle is bundle of energy, and it will just behave like a particle. And same time, you can have other theory from the Maxwell that light is electromagnetic wave and it is just behaving like a wave. Now we have explained the theory of light classical manner so that it is behaving like a wave, and some advanced manner in this two experiment it is behaving like a particle. So light have dual nature. So what we have, light have dual nature. Light have dual nature. Dual nature means it has nature of particle as well as nature of wave. Now let's go for electrons.
Sir,
We have experiment, yes.
sir, from photoelectric effect, shouldn't we get light behaves as a
I
wave?
am not discussing, madam, I am not discussing photoelectric effect right now. I am just giving you conclusion that photoelectric effect is from the photoelectric effect, we believe light is a particle. Okay. And if you, because this is not a part of this course, we have to quantum mechanics. This is the pre-quantum mechanics era. Okay.
Okay.
Okay. So if you want something about this thing, I can give you material. I can give you some extra videos. You can see separately. But this is not a part of this course. We have to stick to our syllabus. This is most important thing. Otherwise, 20-day take it will only for this course, and you will get nothing in the examination. Okay. So be focused on your task. So for the electron, we have Davison Germer experiment, where we have give the theory of matter wave. We have find the experiment, diffraction experiment from electrons, and we have seen that electron is behaving like a wave. So from this theory, it is given electrons are behaving like wave. So these are the thing, electrons are behaving like a wave. And now we have some hypothesis. What is the hypothesis? The first and most important hypothesis, we will discuss this thing when time will come. All hypotheses I will discuss. The first hypothesis is the de Broglie hypothesis. What he say? He said, if particle is moving, they associated a matter wave, and the wavelength of that matter wave is equal to lambda is equal to h upon mv. We will discuss it, don't worry. But right now, so this experiment, Davison-Germer experiment, will verify the matter wave. So it will verify the de Broglie hypothesis. And same time, we have black body radiation. In the black body radiation, it is said that energy of light is quantized. Means the light's energy is not continuous, rather it is quantized. It is discrete. So this discreteness will also come into picture. Again, one experiment, that is hydrogen atom experiment on hydrogen atom spectrum. Hydrogen atom. Again, we have from the spectrum what we have make conclusion that energy is quantized. Don't worry, everything we will cover it. We will cover. But I am just giving you the overview. So what are the overview? What are the new thing other than classical mechanics? According to classical mechanics, light is just a wave. According to classical mechanics, electron is just a particle. From this experiment, we have light is also behaving like a particle, but it doesn't deny it is not wave. Why? Because you have young double slit experiment from light. You have diffraction pattern from light. So some experiment will give the wave nature, some experiment will give the particle nature. Similarly, we have also seen that, okay, electron is a particle. We have lot of collision, lot of scattering. We can see that electron is a particle. But in some experiment, it is also verified that electron sometimes behave like a wave. So it's a confusing state. And due to this confusing state, we need to rethink about our whole nature. And these all experiment leads to evolution of quantum mechanics. But quantum mechanics is not only wave and particle or wave. Obviously, this is one particular aspect. There is another aspect. Let me explain two very important experiment, and then we will try to understand what is happening to the nature. And yes, we are not able to decode this behavior of nature. And obviously, decoding the behavior of nature is all the purpose of science. And due to that purpose, what we get evolution of quantum mechanics after the classical mechanics. So let's try to go for to a particular experiment, and let's go for first experiment. Is basically, it's a very important experiment, and this is Young double slit experiment. So let's try to go for it. So I pre-assume that you know all this information, so because it is out of box from this course. But yes, I have to start from here, just a historical background. Now let's try to go for the two experiments. The first experiment I will discuss a very nice young double slit experiment, and then I will discuss a Stern-Gerlach experiment. Let's see what are these things. So I don't think there is any scope of question right now. So let me go for the experiment, then we will try to discuss this, what is happening here. So let's go for young double slit experiment with the light. So this is the two slits, and there is a screen, and let's say this is slit 1 and this is slit 2. What will happen? I will, and let's say this is the light. So this is the light. What will happen? I will first stop the slit 2 and I allow the light pulse from 1. So obviously light will come here and we have the maximum intensity at the center, and we have this kind of profile. So this is when light 1 is there. Second, if I will just close 1 and I will allow the light pulse from second one, then I will again get this kind of situation. So this is the situation when one slit is open. When one slit is closed, actually. Sorry, one slit is closed. Now I am using for open slit. If both the slit will open, I am using a different color. What you will get? You will get something this kind of profile. So this yellow color I am using for the both slits are open. Obviously, this experiment is well defined by the Thomas Young, I think, and he just say that don't worry, these are nothing but the interference pattern due to two coherent light, and we have this kind of situation. And obviously, if it has intensity I1, it has intensity I2, but when both are open, then I is equal to I1 plus I2 plus 2 times root under I1 I2 cos delta. I think this is the value, isn't it? Yes. 2 times, I think 2 is there or not? Yes. So this is the intensity pattern for this particular thing. So you can just find Yes. So this is the, so main thing is that I is not equal to I1 plus I2. Obviously, this is well explained by the wave nature. The first wave has y is equal to a sine omega t. Second wave have y is equal to a sine omega t plus delta. And finally, they can have the bright and dark features on this. Okay. So this will easily say that light is a wave. So this is the wave nature. Let's try to do this same experiment with the marbles. So this is for the light. This is for light. Let's try to go for the same experiment with the marble. Marble, you have marble ball. So small glass ball, marble ball. So we have just doing this experiment from the marble. Again, we have this slit 1 and we have slit 2. So first, just we are throwing the marble. N number of marbles are going. So they will go either from this slit or this slit. Only we are counting those marble who are just passing this particular slit. So if, so this is my first one and this is my second one. If I will close the second one, I will get maximum marble will be here, and obviously 1 or 2 marble can be deflected. So this kind of thing, this is very sharp kind of feature. If I will open, close first one and I will just allow to pass the marble, then this will something like this. And let's say this is I1 and this is I2. And yes, when we are opening the both slits, then what I will get? I will get exactly same pattern of this. So here I have I is equal to I1 plus I2. So if I am throwing 100 number of marbles, it may be 50 marble will come here and 50 marble will come here. The intensity is nothing but the number of marbles. So this is the experiment done by the marble, and here this will just tell you marble is particle. Now let's try to do this experiment with electrons. So this is the light. Let's try to do this experiment with electron. So this is for the light. I will write electron there. This is light. This is marble. You can marble ball. And please, you can make the size of slit that marble can cross it. So don't worry about this. Now let's try to go for electron. So what we have? We have this slit 1 and we have slit 2. And this is 1 and this is 2. Again, I have closed second. I will send lot of electrons. Just they are going. We have electron gun and number of electrons are shooting from. So then they are only option that they will go from slit 1. So we have this kind of pattern. And if we will close it, then obviously we have this kind of pattern. So obviously we also believe that, okay, you will also believe just like a particle, because we assume that electrons are nothing, but it is a very tiny particle. Now when I am using the different color for the open, both slit is open. So don't worry. Now, if both slits were open, when both slits will open, what was our expectation? Our expectations was that it will just behave like a particle. But what we will get? We will get something like this. Do you know how you will get this pattern? You will get experimentally, you will get this pattern, something like this. Suppose this is a screen. What will happen? Initially, one particle is here, some is here, some is here, and then it will just go like. And what you will get? You will get the intensity pattern kind of thing. As time evolve, you will get something like this. So how this is happening? You will get exactly same intensity pattern whatever we are getting the light. Then we thought, okay, electrons are, some people have said, okay, maybe two electron will interfere because we are sending the lot of electron together. Maybe two electron will interfere, and then they can give this particular type of situation. Then what we have done? Now we have shoot the electron slowly. We have shoot the electron very slowly. One electron will come here. Again, after one electron will cross, then we will slot again here, again some here, again some here, again some here. And as time process, we will get exactly same kind of situation. So obviously, it is not due to interference of electron. Now, just go for the next level of experiment. And what we have done right now, we will just put the detector. We will put the spy behind the electrons. Just we are putting the spy behind the electrons. What is meaning of putting a spy behind the electrons? Means we just want to verify whether electron is crossing from this slit or this slit. It will be a mesmerizing result. And what was the result? We will get this kind of behavior. When we will put the basically spy, then what we will get, I am using the different color for the, when we are putting the spy behind the electron, they will give something like this. So this is the both slit, or this is the double slit. This is for the single slit, and this is double slit plus a spy. What is this? How this experiment can be justified by the common sense? It behaved that electrons like a soul, have life, that he know, okay, the spy is there, okay. And once we will remove the spy, what will happen? This pattern. What is happening? What is happening? And please, this is not a fairy tale, and this is not a sci-fi movie story. It is done and experimented into lab actually. My goodness. Electron sometimes behave like a particle. It is sometimes behave like a particle. It is sometimes behaving like a wave. This is dangerous situation. When we will go for the particle, when we will go for the wave, this is a dangerous situation. But yes, this experiment is a fact. This is a fact, and it will open the new field of exploring that is known as quantum mechanics. So let's go for a next experiment to understand all this thing. So let's try to go for next experiment. So if you have any doubt, and obviously there is a lot of doubts, but I cannot explain all these doubts. Now, what you have to do? You have to just believe on these experiments, or you have to do this experiment. If you have some good lab, such as in IIT and some places, most probably these experiments can be done. But how you will explain it? This is the dangerous situation. And right now, I am not also able to explain it. Yes, we will try to explain it once we understand quantum mechanical formulation. But yes, this experiment is fact, and you have to believe on these miracles. There is no other option. So this is the most important thing. So let's go for
Hello.
next. Yes.
Hello. Yeah, sir, I have
Yes. Yes.
one question.
Hmm.
Sir, what do you mean by when we put a detector, then the
When
electron?
you put the detector means I am just chasing the particle from which slit it is crossing.
Okay, fine. Then,
Okay.
okay, fine. Thank you.
Okay. Okay. But once we will see the input and output, then I will get this.
Sir, what about the
Okay.
third one? When you are using detector, what about the third one? Double slit you said no.
Detector with the spy means this is the double slit. This is for the double slit, D for the double slit. And let us write it spy. Okay. Let us write it spy. Okay.
So when you are using spy, so
Hmm.
then we'll get when you are sending light with through one slit, like that only will get again. Okay.
Yes.
Okay.
No. When we are putting the spy, it is just behave like a this thing. Like a this is the double, both slit is open, but a spy is there. So electron will either cross here or either cross here. There is no any interference pattern. Okay. Okay.
Thank you, sir.
Okay. Let's go for more dangerous experiment than this. So I have started late, so I will take 5 minutes extra. Okay. Otherwise, my class is exactly fixed about the time. So let's go for next experiment. You know polarization. You have done polarization in your early days of physics. So these are basically some unpolarized light. Means all directions are possible. And we are just putting the polarizer in a Z direction. In a Z direction. Then what will happen? Only parallel to this polarizer, parallel to this, let's say these all are electric field. These are schematic diagram, okay? So only the parallel to this polarizer will come there. And again you are putting next slit which is also parallel to Z axis. What you will get? All will cross it. So whatever with the intensity here, you will get the same intensity here also. Suppose I am drawing the 4, then I will also draw 4 here. Now, suppose I am putting the slit something like that in X direction. What you will get? You will get 0. You will get 0. Nothing. 0 means nothing. Okay? Nothing. So this polarization of an electromagnetic wave is well defined. It is well defined, and we can explain it with Molu's theorem and all this thing. You will learn into electromagnetic theory. Now let's go for a next experiment, which is known as Stern-Gerlach experiment. So let's try to. So I am just giving it there. Let's try to go for a Stern-Gerlach experiment. So what is this Stern-Gerlach experiment? I will discuss it in when we will go for the spin chapter. But right now I am just going for the experiment. So this is some black box where we can put the magnetic field. We can change the magnetic field direction. What we have seen, suppose we have put the magnetic field in Z cap direction and we pass the electron. We pass the beam of electrons. What we will get? We will get the electrons will go for 2 levels. It will split into 2 levels. Then we can say, okay, electron have 2 magnetic moment. One can be plus and another can be minus. And what we will do, we will just block the second one. As we are blocking the all other direction here, we are just allowing to only one direction. So also we are allowing to only one direction. And again we are putting the same apparatus, and this is some black box kind of thing, and we can writing SG apparatus in Z direction, means magnetic field is fit into Z direction. And now I will again put SG into Z cap direction. What I will get? I will get exactly I plus. I will get exactly I plus. If this is the intensity, then this will be I naught by 2. This will be also I naught by 2. And this will be also I naught by 2. Means whatever be the intensity, it will just go. So that is the exactly same like a parallel thing. This is exactly same like this. Look at what next. This is the most important thing. Now again I am putting it Z cap, allowing the electrons. It will just go for this, and this minus sign I am blocking it. It will just crossing from here, and I will just put SG into, and this is the Z sign. I am just putting SG into X direction. SG into X direction. So what will be your prediction? What should be there?
Zero.
According to this theory?
Zero.
Nothing. Zero.
Nothing, zero. But what you will get? You will get plus and minus. And this will be, let's say this will be I naught by 2. And this will be get I naught by 4. I naught by 4. Sorry, I naught by 4. There is I naught by 4. So again it will split into two directions. Now this is the more dangerous. Now look at what I am going to do. I am again blocking this one. And again I am putting Z direction. SG into Z direction. What do you expect? What do you expect?
Zero.
Huh? Zero.
I not by
Split
4.
into
I
two
not by
again.
4.
Again plus and
I
2.
not by 4.
By
plus
8.
two.
It will split into two parts. Look at these are generated from Z part itself, and finally it's all lose all the memory of your its initial measurement. Nothing to do with this measurement. You cannot predict what can be the outcomes. And obviously this is not only polarization, this is something else. If it would like a polarization, then obviously what I should find here as 0, nothing else, 0, nothing else. But I will get to splitting again, and the most important thing is again if I am putting the Z, it is generated from the X part of polarization, and this will be again give the 2 part. So this is again done into the experimental lab, and which is obviously you must only believe on this. You must only believe on this. Only one important thing is that you have to believe. Even if you are not able to understand, you have to believe. Because it's an experiment, because it's a law of nature. So you can see at the microscopic level, suppose I am talking about electrons. Electrons have a very weird behavior, which is not exactly particle, which is not exactly wave. Sometime it behave like a particle, sometime it behave like a wave. We should discuss a theory how we can explain all these things. And this is the most important challenge to go for it. So I think I will stop here and I will start from next class. So you can assume this is a 0 class, okay? You can assume this is a 0 class. Why? Because this weirdness of the nature you should feel. This anxiety, these are the anxiety. Randomness. All these things are there. Unpredictability. So what is basic difference between classical and quantum? So if I want to say about the basic difference between classical and
Sir?
quantum, just a minute, just I want to say what is the difference between classical and quantum. So classical mechanics is all deterministic and precise. What quantum mechanics is all about probabilistic and random. Obviously, there is error into measurement, and these error are not due to apparatus. These error are not due to your resolution. These error are the inherent part of the particle. We will discuss it in the next time when we will go for the uncertainty principle and all kind of thing. So these are the inherent part of the particle. Electron is moody, and you have to believe that electron is moody, and you have to treat them as he is very moody kind. Yes, what is your question?
Sir, in the second experiment below, if we put SGZ in the second position after the Z, what will
After
we
the
get?
Z,
There is a
after
Z,
Z, again
there is
Z.
an X, there is an
Yes,
Z.
X. So then you
Ah.
will get this one. You will get this one. Z after this, I will get this one.
Then it will follow the class. Okay.
No,
okay.
no.
Okay.
Okay. Up to this, we have believed that, okay, this is something like polarization. And once I will put it X here, what will happen? It will go up to plus and minus. This is the dangerous situation, isn't it?
Okay, sir. Okay.
Okay. So I think, so this is the first class, and I think this is the 0th class of the quantum mechanics. So from tomorrow, we will start with the vector spaces, Hilbert space, all kind of thing, Kit and Bra notation. So obviously, look at one more experiment. One more thing I am just telling to you. Just tell me, what is this thing? Anyone?
Ka.
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 Ka. Yes, isn't it?
Yes. Yes.
Now, this is the ka. Hindi frame ka. Okay. Now, have you ever asked question why it is ka? Never.
No, sir.
No, sir.
No, sir.
No, never. What? So, somebody have tell you by the assumption this is a ka, and you believe it, and you practice lot of time, and then you believe, okay, this is ka, and let's apply ka for Kamal. Isn't it?
Yes, sir.
So next class we are doing the exactly same thing. We will try to learn new script, and that new script is known as what? Dirac notation. So you cannot ask, sir, why it is named like that. No. First you have to believe, practice it, and then apply it. Okay?
Sir,
Okay, sir.
Yes.
sir, in second case,
Hmm.
in third position, it is Z. It will be I0 by 8.
I0 by 8, I0 by 8.
Yes, sir. If we block the sir, if we block
Sorry?
one part from there. Hello.
Here.
Yes, sir.
Yes.
Then again it will be.
Don't worry. Listen. Don't put your head right now into this particular thing. When we will go for a Stern-Gerlach experiment, we will mathematically solve each and every point. Okay?
Okay, sir.
So this is just experiment. This is just a input and output. What is happening into this black box? Give me time of next 30 classes. You will able to understand each and everything. Okay? So don't unnecessarily raise your questions. I am not able to give the every answer right now. Okay?
Okay, sir.
Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.